Maureen for the invitation, and thanks Mira for the really kind introduction. Thank you for having me here. Let me quickly. Okay, so I'm gonna pretend I'm in the Guggenheim Museum in New York City when I'm presenting. If you, as you can see from my virtual background. This is going to be a work with co-authored with Baron Park, who was a grad student at NYU when we started collaboration, and now he had just recently started his job as assistant professor in Cornell University. So I'm going to focus on this paper, and the paper is quite long. So I have to say, the goal of this talk is to kind of give you an introduction and description of the key ideas, try to make a case for the network approach. But there are a lot of technical details and like detailed results that's going to be presented in the paper. So the paper is coming out, I think, this month in AJS. But if you wanted to read and draft or a manuscript, just feel free to email me. I'd be happy to share. Okay. So, how do I, just a minute, I'm trying to, sorry, does anyone know how I can mute that menu bar of Zoom? Any chance you know that?
What's that, Siwei? Which bar?
Menu bar of Zoom, like showing mute, stop video, like things on my screen, on my slides. So
we don't see it.
We're seeing your slides perfectly.
It looks good.
So it's just mute that. Okay, yeah. Then I'll just try to remember what my, so it's covering the menu bar is covering my slide title. So, but if you can see it, that's fine. Okay, so this talk is going to be about flows and boundaries in occupational mobility. But before that, I also want to just make a case for flows and boundaries in general, especially as it matters for population research and research in social science in general. So I want to make a case that scholars need to think a lot about how they define boundaries when they study how people, household or jobs or ideas move, or the mobility of things. For example, when you study population migration, you care about how you would define the boundaries of geographic regions. Residential mobility, you think about boundaries of neighborhoods. We think about movements across network communities, flows of ideas across scientific disciplines. So in a lot of these cases, we need to aggregate smaller units into larger or more aggregate clusters. And to think about those clusters, we think about boundaries. And such is also the case with intergenerational mobility and intra-generational mobility. When people think about how do we aggregate small units like jobs or occupations in the labor market into more aggregated social classes. So when we think about, and that's necessary because then that's the foundation on which we're going to study rates, like how people move across units, and think about what we call fluidity or rigidity of the system, because we need to see how strongly are the movements contained within boundaries. So I put up this slides because I want to make a case of, just flows and boundaries, or the duality of flows and boundaries exists in a lot of studies when we think about mobility. So in this study, I'm going to focus on the case of intra-generational mobility. So the boundaries that segregate or segments the labor market into clusters that contain the mobility of workers as they navigate their careers. So, and this is of course, important for understanding the structure of the stratification system, structure of the labor market. So stratification scholars often ask questions such as how rigid or fluid are these boundaries in constraining occupational mobility? or has the rigidity, so the strength of these boundaries changed over time. We also care about how these mobility boundaries are associated with outcomes measured in terms of socioeconomic status, like earnings, income, skill levels, or even political attitudes. So these are the questions that are typically asked in the long, in this as a long tradition in stratification literature. And these questions are significant for understanding the system because it gives us an idea of or insights into the class structure of the system, the fluidity, and it also gives us an idea of how the career lines, if you think about the Spillerman's earlier work on career lines, it tells us how the career lines are structured in a society. And for individuals, these boundaries that govern the flow of workers will determine the opportunity structure that individuals face when they're trying to, move through their careers, attain higher socioeconomic status. And these are also important for policymakers because knowing all these boundaries, like the structure of these boundaries governing flows, will give us an idea of where, some jobs are what we call stepping stone jobs. So jobs that are that may help promote upward mobility for those who are relatively moderate or low skilled workers. It could also signal some dead-end jobs in which workers are, just circulating within a cluster of low-end precarious jobs. So these are so understanding these questions theoretically will also give us some insights into potential policy issues. And because I was trained in Michigan as a stratification, like Yushia was my advisor, and I need to cite Blau and Duncan basically in every one of my papers. But it's actually when I was rereading and this American occupational structure, like they at the very front also kind of made a strong case for studying occupational grouping, like I'm quoting here, studying these occupational grouping is defined in terms of the flow of manpower between them through time. So this also reminds us of this fundamental duality connections between occupational grouping, which is basically finding the boundaries that cluster occupations on the one hand, and on the other hand, this flow of workers between occupations. So it is, these two concepts are fundamentally connected in the structure. And this is a more visual conceptualization of what we meant by mobility boundaries or mobility clusters here. So this is a network where you can see the nodes are occupations or jobs, and then the blue edges, lines are the edges in the network that represent the volume of workers that flow between them, and this can be directional. So you see the arrows there. So this is, of course, a hypothetical example, but you can see we can kind of visualize 4 modules in the network. So the modules are defining clusters within which the mobility are relatively frequent, where across which relatively rare. So, and this interestingly also goes consistent with Weber's definition of social classes when he was saying social classes are consisting of the totality of class situations within which individual and general mobility is easy and typical. So this is just, we want to kind of make a case for conceptually, this is quite intuitive to think about boundaries, latent boundaries as naturally defined actually in terms of mobility. Okay, so, and this is of course nothing of what I have just said are new, these are long-standing themes, but in this paper we would also want to focus on 3 of the major challenges that we see in current studies of occupational mobility, particularly as it relates to within or between cluster mobility. So I'm going to go through the 3 challenges and give you examples, and then I'll introduce how the network approach that we're going to introduce overcomes this. So the first challenge is, how should we determine mobility boundaries? And this seems to be, of course, the first question that we think about when we're trying to model mobility. And in existing work, there are several approaches. So of course, the first one is deductive approach, or I think we can also call it theoretically informed approach, where we think about occupational class schemes from the theoretical perspective. So we define social classes according to whatever the theoretical focus we're like the perspective of class that we want to emphasize. There Erickson and Goldthorpe type of big classes and which kind of give you like large categories of, like say, the professional class, manual class, non-manual class. It gives you a fundamental divisions in the labor market that separates very different, distinct divisions of labor. There are also meso class, just a slightly more detailed class schemes by Hetman and Hauser, and these classes are also separating out groups of occupations that share similar socioeconomic standings, class positions in a system. And Wheaton and Grasky later proposed these micro-class categories. It's basically micro occupations, and their argument is based on the division of labor around this micro-occupational closures as the fundamental as playing a fundamental role in defining class. So these are deductive approach. So we come from theories. But the question is, of course, we can use those class categories to study occupational mobility, and that has been done. But they do not necessarily capture mobility boundaries, as we have just seen in the previous picture, where the boundaries are latent ones that are separating clusters of worker flows. So it's not guaranteed, because those theoretical approaches, while significant, are not necessarily mobility, starting from mobility. Of course, there are empirical approach too. So what if we try different types of partition? So when I say partition, it's the equivalent of aggregation. So we partition the system in different ways, and we think about whether, and we see which one does better depending on whatever criteria we impose. Actually, Ronald Breiger and Lou Goodman in the 1980s, they have several papers formally laying out this, theoretical and mathematical foundations of how to judge which type of partitioning is better. So that's doable, of course. However, I want to remind you that with only 10 occupations, there are 21,000 ways to combine these occupations. And with 20 occupations, I don't even know how to say this number, but there are many, many ways to draw boundaries between those occupations. Of course, we can eliminate some of those that don't make sense at all, but still, just empirically, there are a lot to test, and we have to rely a lot on human judgment or experimentation to decide what set of candidate combinations we're going to start with. But in the modern stratification, in modern surveys done by Census Bureau, the occupational classification has 300 or so, or 400 categories. So it's just empirically impossible to work out all the possible ways by hand and make a judgment of which one works better. So we still need something to determine the mobility boundaries. And this is just to give you an example of what happens if we use those class boundaries, occupational class schemes, like big or micro classes, to study mobility. What if those class schemes align with or do not align with mobility boundaries? So in this case, we call it consolidated class and mobility boundaries, where the red dashed lines are class boundaries. So and then the blue and the network is just given as hypothetical. So in this case, the class boundaries are doing a good job capturing the mobility boundaries. So they're consolidated, and we have no problem of labeling mobility within and across classes, because within class movements are also supposedly within clusters of mobility. But in the second case, I'm showing the case of de-aligned class and mobility boundaries, where the class boundaries cross-cut some of the mobility boundaries. So they do not perfectly align with each other. So in this way, we might be labeling some of the within cluster movement as between class movements. So what appears to be a fluid society might simply result from the fact that the class boundaries are not the true boundaries that are segmenting the mobility system. So we might be mislabeling some of the within cluster flows as crossing boundaries. So with this example, we're just trying to make a case for why maybe we need to, like, in addition to the existing class schemes, we could also think about a way to uncover the mobility boundaries. And then we're going to compare that to class boundaries. Okay, so the second challenge is how to incorporate changes in mobility boundaries over time. So most existing literature in stratification research start with the assumption that the class boundaries are invariant over time. And this is a helpful, and actually a lot of time it makes sense. So because it's necessary to separate out changes in mobility patterns from changes in the underlying class structure. Because when we, like as demographers or mobility scholars, when we study change, we need to hold others constant so that we can look at one type of rates at one time. So this is necessary. But in reality, we could also think of a lot of reasons where mobility boundaries themselves evolve over time. So for example, suppose one class, a big class, over time splits into two separate occupational mobility classes. So if we stick to a time invariant class scheme, so we always disregard the separation between C21 and C2, which are the two subclasses that C has split into, then we may be mislabeling a lot of this movement between C1 and C2 as within class moves. Or we might not be able to recognize the fact that actually within this aggregate class C, what appears to be a high volume of flows is actually flows within two quite separate subclusters. So and a lot of more complicated changes may happen over time. And if you read like Reeder and Graske's original paper, when they proposes this microclass structure, they also acknowledge the fact that their class scheme is more or less kind of sticking to the 1970s census occupational scheme. So that's necessary because you want to standardize that so that you can compare rates. But because of that, their classification scheme might be increasingly inaccurate in capturing the true boundaries separating mobility, simply because of this coding, the coding practice. So the issue is how will we at the same time also identify changes in the mobility boundaries over time. So, okay, so the third challenge is how to incorporate multi-step movements. So prior work tried to, when we characterize occupational mobility, a lot of attention has been paid to one-step moves from origin to destination. And before that, I want to emphasize that it's not like none of these works has thought about multi-step movements. Actually, we read papers by, say, Ed Lauman in the 1960s, already starting to talk about the insufficiency of attending only to one-step moves. But what we're saying here is methodologically or analytically, it is still not, there is still a lack of theoretical basis or analytical basis for how to incorporate these multi-step connections between occupations. So, and in reality, a lot of times mobility takes several steps to realize, and you don't always move from one origin destination to a destination of occupation. So a lot of times you move through several steps in this, so what we call path in a network until you finally end up in a destination occupation. So it might be not necessary for methods to incorporate those multi-step movements. So, and to kind of overcome some of these challenges, and also to kind of answer to this, like a lot of the challenges have been mentioned in the in literatures in the past half century or so, but kind of to answer the call to formally, address these challenges, we propose a network approach, and apply that to occupational mobility data. So the nodes are occupations, and by occupation here, just operationally, I'm referring to this detailed, say 300 category or 500 category census occupational categories. And by edges, we mean the between occupation transitions. They're directed, so origin to destination. They're weighted by the volume, the number of workers within each occupation of each move. And it's also, so you might think about the volume also in terms of the occupation size, because larger occupations by definition would have a greater number of workers in them and therefore a larger volume. So the algorithm itself also accounts for the differential occupational size to start with. So we're going to apply something called the InfoMap algorithm, which is a community detection algorithm. So for those of you who are who have some background in network science, the method for discovering modules or clusters in the network is called community detection. So InfoMap algorithm, we chose that mechanism because it's one of the few clustering algorithms that performs very well with weighted and directed edges, although it doesn't have to be a weighted and directed edges. Yeah, and second, this is also just computationally, it's one of the best performing algorithms so far. And we included a lot of details in the paper regarding how we exactly implemented this. But metaphorically, the InfoMap algorithm basically look for clusters in the network by looking at what we call random walks. So it's metaphorically, it clustered the network of occupations into modules or into clusters within which a random walker will spend more time and across which random walker will spend less time. So these pictures are taken from Roswell and Bergstrom groundbreaking paper where they introduces the algorithm. So here on panel A, you can see this orange lines are mimicking this random walk. And you can imagine a hypothetical worker navigating the labor market. So this worker will likely spend more time in some group of occupations before he or she moves into another occupation, simply because there are barriers that are putting up cost for crossing into another cluster. So that's the reality. And computationally, if you want to record the movements of a random walker, what would you do? You want to put down the names of the nodes that this worker has spent time in, right? So basically, we use something that we have the concept of description length, which means that we're using, these are binary coding. So we use binary codes to record the movements, the path that this hypothetical random walker has gone through, following the volume of worker, following the channels between each occupation. So that's what you see in panel B. So here, the code will be very long because this worker, you need to characterize every step. So, but to learn structure of this network, we want to compress the data. We want to compress the information that we have so that we can distill the real structure. So the way that InfoMap compresses information is to come up with a different, you can think of this as a hierarchical labeling system in which we put like a higher level label to occupations, or in this case, these nodes, where the workers tend to spend a lot of time within before moving out. So this is like if you have streets in New York City and streets in Philadelphia, you don't want, and if people are moving, you don't need to record every time saying this is 3rd Street in New York City, this is 24th Street in New York City, this is 27th Street in Philadelphia. You don't need to say every time the city name because you know that a worker or a resident is going to spend a lot of time within each city before moving to another city, because most of the mobility are probably happening within a smaller region. So because of that, we can label the cluster first and then label the nodes within cluster. So we're labeling cities first before labeling the streets. So that and by doing that, if the label is done very well in the sense that it is really reflecting clusters that contain mobility, then naturally we will need a shorter description length to describe a random walker's move, because we don't need to say New York City every time when this person is moving within New York City. So that's what basically intuitively what the InfoMap algorithm does. So, and then in panel D are showing these 4 like higher level cluster labels, where this is what we ended up as the cluster. So InfoMap algorithm optimizes the minimum code length principle. And that's also intuitive. If you, in the example I just gave, it's intuitive for thinking about mobility. Okay. And for technical details, read the paper. And then going to the data. So I'm going to apply that algorithm to this occupational mobility data. And we're using this data, the March ASAC supplement in CPS, because it has questions of this individual's occupation in the previous year and in the current year. And this is retrospective, which is actually important for us because the CPS, if you know the data well, they also have monthly linked surveys. So a person reports his or her occupation at each wave. And we can link that. So occupational transition can also be measured in that way, rather than retrospectively in our case. But we think the retrospective measures are actually better because a lot of the reportings of occupational transitions what seems to be a transition might result simply from the fact that the coder in the Census Bureau are coding the same occupation differently, or the describer is describing the same occupation differently. So there is a lot of noises that's added to this if we match 2 independently answered occupation questions. So, and this is actually an important decision that took us several months to make. We tried both data. The data that, the data with the linked months data is just very noisy, and we look at the technical reports, it actually makes sense to, and they explained, and there's also some programming transitions across CPS years, and it turns out that it actually makes more sense to look at occupation when people are reporting them at the same time. Okay, so there are approximately 300 occupations per year. We say approximately because it's a survey, so probably there might be years when the really small occupations don't have a single observation who answered the CPS survey. So we also try to combine different moving average windows to increase the sample size, and the results are quite consistent. And we're not including stayers. So for those who are familiar with mobility tables, stayers are those who are in the diagonal cells when they don't move occupation into year. And of course, that's losing a lot of observations. But because this study is mainly to identify clusters that are separating occupations, so between occupation connections are more important than within occupation gravity of mobility. So we're excluding stayers. And there are a lot of NEC occupations. If you work with census coding, you see a lot of not elsewhere classified occupation. And it is, so our main analysis excluded those because those are also noisy occupations where a lot of times people just put in occupations that are difficult to classify into that bag. So it ended up being a very heterogeneous one that messes up, sometimes could mess up the algorithm because it has tests anywhere because it's a kind of a very heterogeneous occupation. The results are quite consistent if we have those in. And we drop imputed occupations. Okay, so how much time? Okay, so I'm not going to the technical detail, but I'm just putting up the slides here to say that we would also need something to measure the the persistence of moves. And by persistence, I mean the within cluster persistence. So the strength of the clusters in constraining mobility is reflected in the facts that there are relatively more frequent mobility within clusters versus between. So, and that's what those modularity measures in the network science usually measure. So this modularity in particular is called link rank modularity. So it's a little bit different from the basic modularity measure if you read network literature, in the sense that it also incorporates multi-step moves. So this means that we're not only considering the flows that are taking one step to realize, but also we're also taking into account the flows that are taking multiple steps to realize in the network. So the modularity, which is the measure of the boundary's rigidity, also accounts for the fact that some workers may take in loops within groups of occupation. Okay, so I'm going to go through selected results. I think I have 4 graphs there. There are, I think, maybe 40 graphs in the paper, including appendix. So there are a lot of results that we did, but I think it's useful to kind of show here some of the main findings that I think informs our conclusion. So the first plot I'm going to show is a descriptive plot, although it's not that descriptive because it's a summary of a summary using some network measures. So here, for simplicity, we're breaking down this 20 year period into 3 discrete periods, and we're showing the labels labels are numbers, right, from 1 to 21, and these are just cluster, like these are these numbers are not that meaningful, except that they're just ordered in terms of the size of occupation in the first period. So what we want to show here is how these clusters, so each of the dots is a cluster that we identified using the algorithm. And what we want to show here is how these clusters split or sometimes merge or evolve in complex ways or across periods. So for example, on the left-hand side, we're showing this, so you can see the lines. The grayscale of these lines reflect the amount of occupations that are changing from one cluster to another cluster. For example, if you look at cluster 1, you can see that it split into several smaller clusters in the second period, right? So look at cluster 1 in the first period. It kind of follows divergent path into this different clusters in the second period. And if you look at on the left plot, if you look at cluster 9, it's something that some occupations merge into one bigger cluster, but later split into large separate clusters. So I'm not going to describe the plot here, but this is giving you a visualization of the fact that the clusters themselves are changing over time, in addition to the rates of moving between clusters. Okay, so the second plot that I want to show is whether the rigidity of class boundaries or mobility boundaries has changed over time. And this is one of the questions that we always care about whenever we look at a mobility table. My first question that I try to think about is, the rigidity of the system. So here, rigidity is measured by modularity that I introduced earlier. So it's basically how strongly do flows tend to cluster within boundaries. And the graded areas are confidence intervals. So you can see that rigidity has remained relatively stable up until 2010 or 2009, and after which it showed an upward trend. So, and we did that in a number of different ways, and this upward trend shows up quite consistently. So it's not, due to noise or a fluke of this data. So basically, this is suggesting that the boundaries, whatever boundaries there are governing occupational mobility, those boundaries are strengthening or becoming more rigid in governing or containing the flow of workers over time. So this is one of the key findings. It actually, the labor market in terms of how segmented it is in terms of boundary strengths has been quite stable up until the recent years, where the segmentation becomes more becomes stronger. So another thing that we did is to another thing that we did is to compare our mobility boundaries with the boundaries that we have typically used in other stratifications like mobility research. So those are the macro, meso, and micro classes in the stratification literature. So as you can see, so we're using something called mutual information. So in brief, this is just a measure of how well these two class schemes align with each other. So the higher the value, the more aligned, the more similar the two classification schemes are. So, and here I'm comparing the mobility boundaries that we have learned from the data to this class boundaries. So what I'm showing is that actually these mobility boundaries are becoming increasingly de-aligned from these class boundaries. So they're becoming increasingly dissimilar, different from the class boundaries. And which is also making a case of course, standardizing class boundaries to an earlier date is useful analytically. It might mean that we're using some class scheme that are increasingly inaccurate in reflecting the true latent mobility barriers in today's world. So, and I think this downward trend is also showing the value of coming up with an algorithm that constantly updates itself to reflect on the changing boundaries in the labor market. Okay, so and next set of results, we're going to look at the modularity, which is the rigidity of boundaries, when the and compare that across mobility boundaries, which is what we have discovered with the class boundaries, the macro, meso, and micro class boundaries, which have been used, which are designed for other theoretical perspectives. So probably not surprisingly, mobility boundaries which is the solid line, does do the best in separating occupational systems into clusters that are that have relatively high volume of flow within and between, which is why we see a high modularity. So this is, of course, might not be that surprising because mobility boundaries are designed to better capture those. But I think it's confirming that this is doing better. And I would also want to remind you that this algorithm itself is not maximizing modularity. So we're not basically, doing this unfair race where we're setting as target something that we're optimizing. So anyway, so the highest level of mobility boundaries modularity confirms that. And it's also interesting, and if you look at the modularity, micro classes, this most detailed classes, has the lowest modularity because it is, so at the micro occupation level, so the smaller clusters are not that distinct. So there is a lot of between micro class mobility. So this is what this is saying when you see the lowest level. The macro class and meso class are in between, so they are doing a pretty good job of separating clusters of mobility, although probably not as good as the mobility boundaries that we're using. So another thing is, it's probably not easy to see with your bare eye, is that the gap between mobility boundaries, so between the highest line and the three lower lines, are also widening over time. So if you, I have another set of results when you just calculate the difference of modularity between mobility boundaries with the other class boundaries, you can see that, so mobility boundaries is doing increasingly better in capturing that. And this is also consistent with the observation that a lot of these occupational class schemes are probably better suited for studying to the coding system that are in the 1970s and to the 1990s. Okay, So the last set of results, so in the paper, we showed us a set of results where we look at how strongly do the boundaries associate with outcomes in terms of, say, income or what else do we, I think earnings or attitudes. So we tried different ways, but I think one of the most interesting results here is the association between boundaries and skills. So the R squares are, so this is simple regression models where we regress occupational skill levels measured from ONET data. So we kind of compiled the ONET skill measures to the boundary and to the coded boundaries, and then to look at how strongly do the boundaries separate occupations that are scoring differently in terms of this 10 skill measures. So, and as you can see, we see an increasing trend in a lot of these cases. So especially like programming skills, managerial skills, miscellaneous technical, science and engineering. So you see quantitative. So you see this upward trend across these different skill measures. So what this is saying is that increasingly so in the recent years, the boundaries that are separating occupational mobilities are increasingly separating occupations that require different levels of skills. So skills are kind of becoming an increasingly important feature that are determining or at least reflecting how these mobility flows are contained. So this is one of the findings that we also think are quite interesting. And of course, you might want to compare to the occupational class scheme, but that's not really possible because the trend is not possible because the class schemes themselves are invariant over time. So the fact that we see this changing association over time is because we incorporate the overtime changes in mobility boundaries. So if you stick to a time invariant class scheme, you wouldn't be able to reflect this changing association between boundaries and different types of occupations. So we think this is also a payoff to this approach. That's of course Warren's future study. Okay, so to wrap up, so in the results I'm showing you today, substantively, we've shown that mobility boundaries are becoming increasingly rigid from the late 2000s. So the labor market, the latent boundaries in the labor market are becoming more strongly segregating worker flows. And the barriers of occupational mobility are increasingly shaped by the skill requirements of occupations. And more broadly, we think this approach provides the promise, like kind of show the promise to analyze mobility from detailed occupations, from the most detailed movements, rather than starting from predetermined class categories, regardless of how large the classes are. And we also think this also provide a way to discover structure features. So if you think of extracting information from very detailed large data, I think this provides a way of kind of compressing the information into structurally meaningful patterns that I think first it's also, this shows how it's possible computationally. It also shows that a lot of these old long-standing theoretical ideas can, in terms of when Breiger or Blau and Duncan early work are thinking about how mobility boundaries should reflect flows, a lot of these ideas can be operationalized maybe with some of the more recent computational and statistical advances. So I think that's all. Yeah, thank you.